What is a decision tree algorithm, and how does it work? A decision tree algorithm is a supervised machine learning algorithm used for both classification and regression tasks. It works by recursively partitioning the input data into subsets based on the values of their features. The algorithm begins with a root node that represents the entire dataset and chooses the feature that best splits the data into subsets, which maximizes the separation between the classes in classification or reduces the variance in regression. Each split creates a new internal node in the tree, which is connected to its parent node through a branch. The process continues until a stopping criterion is met, such as a maximum depth of the tree or a minimum number of samples required to split a node. At this point, the leaf nodes are formed, which represent the class or value of the target variable. During the prediction phase, the algorithm traverses the decision tree from the root node to the corresponding leaf node, based on the values of the features in the input data. Finally, it assigns the output of the corresponding leaf node to the input data. Decision trees are easy to interpret, require little data pre-processing, and can handle both categorical and numerical features. However, they are prone to overfitting and may have poor performance on complex datasets. What are some common impurity measures used in decision trees? Impurity measures, also known as splitting criteria, are used in decision trees to evaluate the quality of a split in a node. The aim of impurity measures is to find the split that results in the most homogeneous subsets of the data. Some of the commonly used impurity measures in decision trees are Gini index. The Gini index measures the probability of misclassification of a random sample from a given node. It ranges from 0 to 1, with 0 indicating a pure node and 1 indicating a completely impure node. Entropy. Entropy is a measure of the uncertainty or randomness in a node. It ranges from 0 to 1, with 0 indicating a pure node and 1 indicating a completely impure node. Misclassification error. Misclassification error measures the proportion of misclassified instances in a node. It ranges from 0 to 1, with 0 indicating a pure node and 1 indicating a completely impure node. Information gain. Information gain is a measure of the reduction in entropy or increase in homogeneity achieved by splitting a node on a particular feature. The feature with the highest information gain is selected as the splitting feature. Variance reduction. Variance reduction is used in regression trees and measures the reduction in variance achieved by splitting a node on a particular feature. The choice of impurity measure depends on the problem domain and the type of data being used. In general, the Gini index and entropy are the most commonly used impurity measures in classification problems, while variance reduction is commonly used in regression problems. How can you prevent overfitting in decision tree algorithms? Overfitting is a common problem in decision tree algorithms that occurs when the model fits the training data too well, resulting in poor generalization performance on new data. Here are some ways to prevent overfitting in decision trees. Pruning. Pruning is a process of removing the branches or nodes from a decision tree that do not improve its performance. There are two types of pruning: pre-pruning and post-pruning. Pre-pruning stops the tree from growing before it becomes too complex, whereas post-pruning involves removing branches or nodes from the fully grown tree that do not improve its accuracy. Regularization. Regularization is a technique used to add a penalty to the objective function of the decision tree algorithm, which reduces the complexity of the model. The most common form of regularization is the L1 and L2 regularization, which adds a penalty term to the cost function based on the magnitude of the coefficients. Minimum sample split. Setting a minimum sample split threshold will prevent the algorithm from splitting a node if the number of samples is below a certain threshold. This can help to prevent overfitting by limiting the depth and complexity of the tree. Feature selection. Feature selection is the process of selecting the most important features for the decision tree algorithm, which can reduce the complexity of the model and prevent overfitting. This can be done using techniques such as correlation-based feature selection or recursive feature elimination. Ensemble methods. ensemble methods such as random forests and gradient boosting can help to reduce overfitting by combining multiple decision trees into a single model. These methods can also improve the accuracy of the model by reducing bias and variance. How do you handle missing values in a dataset when building a decision tree? Handling missing values in a dataset is an important pre-processing step in machine learning, including when building a decision tree. Here are some ways to handle missing values in a dataset when building a decision tree. Drop missing values. One option is to remove all rows or columns that contain missing values from the dataset. However, this may lead to a loss of valuable information, especially if the missing values are frequent. Imputation. Another option is to replace the missing values with a value that represents the distribution of the other values in that feature. There are several methods for imputation, including mean imputation, mode imputation, median imputation, and KNN imputation. Create a separate category for missing values. If the missing values are informative, you can create a new category that represents missing values for that feature. This can help the decision tree algorithm to learn how to handle missing values. Use algorithms that can handle missing values. Some decision tree algorithms, such as CART, classification and regression trees, can handle missing values natively. In these algorithms, the missing values are assigned to a separate branch or node based on their relationship with the other features. It's important to note that the method chosen to handle missing values can have a significant impact on the accuracy of the model. Therefore, it's recommended to experiment with different methods and evaluate their impact on the performance of the decision tree algorithm. Can you explain the concept of pruning in decision trees? Pruning is a technique used to reduce the complexity of decision trees by removing branches or nodes that do not improve the accuracy of the model. The goal of pruning is to create a simpler tree that generalizes well to new data, rather than fitting the training data too closely and overfitting. There are two types of pruning, pre-pruning and post-pruning. Pre-pruning. Pre-pruning involves setting stopping criteria to limit the size of the tree during the training phase. For example, you can stop growing the tree when a node has less than a certain number of samples, when the maximum depth of the tree is reached, or when the decrease in impurity is below a certain threshold. Pre-pruning is a simple and efficient way to control the size of the tree and prevent overfitting. Post-pruning. Post-pruning involves growing the tree to its maximum size and then removing the branches or nodes that do not improve the accuracy of the model. One way to do this is to use a validation set to evaluate the performance of the tree after each branch or node is removed. If removing a branch or node improves the accuracy of the model on the validation set, it is pruned. The tree is pruned until the accuracy on the validation set stops improving. Post-pruning is more computationally expensive than pre-pruning, but it can lead to better results because it considers the interactions between the nodes and branches of the tree. Pruning can help to reduce the size and complexity of the tree, improve its interpretability, and prevent overfitting, which can improve the performance of the decision tree algorithm on new data. Can you explain the concept of information gain and how it is used in decision trees? Information gain is used in decision trees to determine the best feature to split a node. The feature with the highest information gain is selected as the splitting feature, because it results in the greatest reduction in entropy or increase in homogeneity of the subsets. This process is repeated recursively for each subset until all examples belong to the same class, or a stopping criterion is reached. Information gain is a commonly used splitting criterion in decision trees, because it is easy to calculate and interpretable. However, it has some limitations, such as the bias towards features with many values and the tendency to favor features with high cardinality. Other splitting criteria, such as the Gini index and the gain ratio, have been developed to address these limitations. How does the random forest algorithm differ from a single decision tree? Ensemble learning. Random forest is an ensemble learning method that builds multiple decision trees and combines their predictions. In contrast, a single decision tree is a standalone model that uses a single tree to make predictions. Sampling. Random forest uses bootstrapped samples of the training data to build multiple decision trees. Each tree is built on a different subset of the data. In contrast, a single decision tree uses the entire training dataset to build the tree. Feature selection. Random forest selects a random subset of features at each node to split the data. This helps to reduce the correlation between trees and improves the generalization performance of the model. In contrast, a single decision tree considers all features to split the data at each node. Voting. Random forest combines the predictions of multiple decision trees by taking the majority vote of their predictions. This helps to reduce the variance of the model and improves its accuracy. In contrast, a single decision tree uses its own prediction to classify the data. Regularization. Random forest uses regularization techniques, such as max depth and min leaf size, to prevent overfitting of the model. In contrast, a single decision tree can easily overfit the data, especially when it has a large depth and a small number of samples. Overall, the main advantage of random forest over a single decision tree is its ability to reduce overfitting and improve the accuracy of the model. Random forest is a popular algorithm in machine learning, especially for classification and regression tasks, due to its high accuracy, scalability, and robustness.